right. So, we are taking more notes on ellipses. So, if you guys remember, the formula for an ellipse was x minus h squared over a squared plus y minus k squared over b squared equals 1. Okay? And we looked at vertices and covertices, right? And we looked at how to find the major axis and the minor axis. And we knew that there was a point on the graph called the focus. So there were two of them. If we talk about them plural, we have foci or foci, depending on who you are. And we hadn't talked about how to find those, so that's what we're going to talk about today. Okay? And then we have one more thing we're going to talk about, and that's eccentricity. And the eccentricity just says how much have you squished it, how close is it to being a circle, or how squished is it, how far is it away from being a circle. That's what that talks about. Okay? So, if we look at this, the way that you find the focus is you start with the equation c squared equals b squared minus a squared, or c squared equals a squared minus b squared. It depends on which one is bigger. So underneath here, I'm just going to say bigger minus smaller, because I don't need you guys to memorize that. I just need you to know that you subtract them, and you always do bigger minus smaller. Okay? Okay, and we're going to write a note to ourselves. The focus is a length of C away from the center on the major axis. So if you guys remember when we drew the picture yesterday, we always said that each focus was a little ways in from the vertex, not the covertex, the vertex. So the vertices happen on the major axis, the foci do as well, or the foci if you like that better. Okay? So each focus is a length of C away from the center, and it shows up on the major axis. Okay? So it's between the center and each vertex. Okay. Eccentricity determines how circular an ellipse is. Determines how circular an ellipse is, and then hold on. Let me look at the book and just make sure I do this part right. At the old school I was at, we never found the eccentricity, but it's not hard to find. Okay, and the formula for this is E equals C over A, or E equals C over B. And again, you just look at the denominator that was bigger. So if your a squared was bigger, then you would use the a value. If the b squared was bigger, you would use the b value. Okay? And the c value is what I described up there, is that you find c squared by doing b squared minus a squared, or a squared minus b squared, whichever one is bigger. Okay? So use c or b, whichever is bigger. A or B? Oh, A or B. Sorry. That's an A. See? All right, use A or B, whichever is bigger. So when it's written like that as C divided by A, C divided by B, you're finding a ratio. And so that value that you get for eccentricity, the value is always going to be between 0 and 1. Okay? So always between 0 and 1. Okay, so what we're going to do is we're going to take an ellipse, just like we did yesterday. We're going to draw a picture of it, just like we did yesterday. We're going to find the center. We're going to find the vertices. We're going to find the co-vertices. We're going to find the major axis. We're going to find the minor axis. And then we're going to find a few extra things now that we've already been introduced to it. So we're going to find the foci. We're going to find the eccentricity. And then we're going to find the length of the major axis and minor axis, which is not difficult. That's why I'm not giving you a formula. Okay? So this unit, as you can imagine, it just has a lot of vocabulary words. Have you guys noticed that? Yeah. Lots of vocabulary words. Okay, so we just want to make sure that when I say what words we know what to look at. And that all these numbers are relatively easy to find. We just have to understand the words and what they mean and what part of the picture we're looking at. Okay, so here is the problem we're going to work with first. We're going to have x plus 2 squared plus y minus 3 squared over 16 equals 1. And the instructions, I'm going to say find all the things because I don't want to list them all out. Find all the things. Okay. So the center is -2, +3. Are the vertices going to be left and right or up and down? They're going to be up and down. Why are they up and down? Because of 16 underneath the y. Okay, so for the vertices, we're going to go up and down how much? 4. Okay, so if I take the point -2, 3, and I go up 4, what's my new point? -2, 7. And if I take the point -2, 3, and I go down 4,
-1.
Yep, -2, -1. Okay, so -2, 1, 2, 3, 4. Okay, so there's my vertices. All right, what number should have been underneath x? 1. That's why they didn't write it. Okay, 1. So our co-vertices, what are we going to do to get the co-vertices? Left and right 1. So if you have the point -2, 3, and you go to the left 1, -3, 3. If you have the point -2, 3, and you go to the right 1, -1, 3, okay. And now we have enough information that we can sketch our ellipse. Okay. And yesterday we also found the major axis and the minor axis. Is the major vertical or horizontal? Vertical. It's the line x equals -2. So if the major axis is this vertical line that cuts through, oh, it covered it up completely. The vertical line that cuts through the shape, then the minor axis would be, yeah, y equals 3, the horizontal line that cuts through the shape, y equals 3. And that is everything that we found yesterday. So now we're going to go a little bit further than that, okay? So the easy things to find are the length of the major axis and the length of the minor axis. So actually, don't just say length. That's silly. Length of major. Now, to find the major axis, to draw that part, we went up 4 and we went down 4. So what's the length? 8. And the length of the minor axis would be
3.
Not 3. 2. From the center, we went right 1 and left 1. So the length is 2. Okay? All right, now for the focus, for the foci, to find both of them, we're going to do c squared equals a squared minus b squared, or b squared minus a squared. We're going to do whichever one is bigger. Bigger minus smaller. So if you look at the bottoms, you have 1 and 16. We're going to do, we subtract bigger minus smaller. 16 minus 1. So c squared equals 15. And so c equals, they're already squared. Right? When they're written on the bottom, they're already squared. So square root of 15. So the c value equals the square root of 15.
Are they always going to have weird numbers like that?
Huh?
Are they always going to be weird numbers like that?
Yes. So if the c value is nice, then your a or your b value is probably going to be weird. If your a and your b value are nice and your c value is going to be weird, you're probably not ever going to have all nice numbers. And that's because this relationship where we've got squareds in there, somewhere you're going to have a number that doesn't work out well. Yeah?
I thought you don't have plus or minus.
We don't have plus or minus because we know this is a length. And so lengths have to be positive. Okay. So our c value is the square root of 15. Now we said that the c value shows up, that the focus shows up on the major axis. It's on that same line that your vertex is on, not your co-vertex, your actual vertex. So that means that this particular time, the focus goes up from the center and down from the center. And the amount that it goes up and down from the center is a length of square root 15. So the way we're going to write this is we're going to say that the focus, each focus is -2. The x coordinate's going to stay the same because we're going up and down from that point. So the first focus is going to be if you take 3 and you add the square root of 15 to it. The second focus is going to be if you take 3 and you subtract the square root of 15 from it. So these are my perfect exact answers. If I want to actually see where the focus truly would have shown up in the picture, then I need to see what the square root of 15 is. Anyone have it? Square root of 15? It's very close to the square root of 16, so it should be slightly under what number? It should be slightly under 4. So square root of 15 is 3.872. All right. So from 3, if we go up 3.87, then we're going to be really, really close to our vertex. So there's the focus there. If we take 3 and we subtract 3.87, we're going to be really, really close to our other vertex. So I'm drawing extra little points. Those are each of the foci, or focuses, foci. I did all the plurals right there. All right, did everyone draw each focus in on their paper? It's very, very close to each vertex. Okay, so we've got that drawn. Then we can go ahead and find the eccentricity. Chris, I left some letters out. Eccentricity. So our eccentricity is going to be, for this one, c divided by, should I divide it by b or a?
B.
B, because that one's bigger, right? C divided by b. So the c value is square root 15. The b value is, it's not 16. It's 4. It's the square root of 16, which is 4. All right. So we can go ahead and say that eccentricity is square root 15 over 4. and call it good. So those are all the different things we could possibly find. Okay. I think what I'm going to let you do is do a couple practicing just that. After we practice having an equation and finding all the things for it, I'm going to start giving you clues, and I'm going to ask you to use those clues to find the equation. So kind of work backwards. And if you guys have noticed, we have a lot of different clues we can have, right? They are not going to give you all these clues to find the equation. They're going to give you like 2 of these, and then you have to find the equation from that. So we're going to practice this first, and then we're going to start using our brains to kind of go backwards and see if we can come up with the equation from some clues. Okay? All right.
Like 2 days ago, Sunday, we girl.
All right, find the equation of an ellipse with a focus at 3, -3, and vertices at 5, -3, and -1, -3. So typically when you approach a problem like this, one of the first things you want to look for is to see if there's any way you could possibly figure out what the center is, because the center is like the majority of your equation. And you have to make sure you understand what the different words mean and what they tell you about the problem. So in this, they gave us vertices, not co-vertices. So since they gave us vertices, what does that tell us? The center is going to be in between them. And if you guys notice, do you see how the y-coordinates of the vertices are the same, but the x-coordinates are different? That means that our ellipse is wider than it is tall, because the vertices are the points that are the furthest apart. Does that make sense? It's wider than it is tall. Okay, so how could we find the center? Yeah, it's going to be the midpoint. It's going to be the middle of those two. So we're going to go ahead and say to find the center, we're going to do 5 plus -1 divided by 2, and -3 plus -3 divided by 2. So if we do 5 plus -1 divided by 2, so that's an x-coordinate of 2, -3 plus -3 divided by 2, it's just going to give us -3, right? So if both of the y-coordinates are -3, that would make sense that the center also was at -3. Yeah. Okay. How far away is 2 from 5 or 2 from -1?
3.
They're a length of 3 away. Okay. So let's start writing our equation and we'll see what all we can fill in. So I have x minus 2 squared over something plus y plus 3 squared over something equals 1. Right? And we know that the center goes left 3 and right 3 to get to the vertices. So that actually tells us a number that should be underneath x. It's 9, right? 9 is the number where if you took the square root of that, that would tell you to go left 3 and right 3. Okay? So we know that 9 is the number that shows up underneath the x. We know that since those were the vertices, that this 9 has to be bigger than whatever this number is, because those were vertices, not co-vertices. Yes?
I totally didn't understand what you meant. How did you find, 9?
So we could see that from 2 to 5 is a length of 3.
Yes.
And from 2 to -1 is also a length of 3. So if you think about what number had to be there to tell you to go left and right 3, it would have been 9. Because the square root of 9 is 3. Okay. How far is the center from the focus? How far is the center from the focus? It's a length of 1, right? You guys see how the y coordinates are the same?
Yeah.
But the x coordinates are a length of 1. Okay? So that means that we have an a value of 3. We went left and right 3 to get our vertex. We have a c value of 1. We went left and right 1 to get the c value. How do we typically find the c value?
Divide.
You take the bigger minus the smaller, and that equals c squared, right? So we're going to say here, we're going to say a squared minus b squared equals c squared. We know that the bigger number is 9, right? So 9 minus b squared equals, we know that c is 1. What should c squared be? 1. So 9 minus whatever b squared is needs to equal 1. So how do I solve that for b squared? Minus the 9. Negative b squared equals negative 8. And so positive b squared equals 8, right? So b is the square root of 8. So if we wanted to continue graphing this, then from the center we would have to figure out what the square root of 8 was, what that decimal was, and we would go up and down from the center a square root of 8, and those would be our other dots, right? Those are our other points. When we figure out what number goes underneath the fraction, do we use the b value or the b squared value? B squared. So what should I put underneath the fraction? 8. And all I wanted was the equation, and that's my equation, so I'm done. Okay, so they didn't give us a lot of information, but we had to just think through the information they gave us, and then we could do the problem. I would say that if they give you the focus and the vertex or the co-vertex, in my mind, those are probably the most difficult questions you're going to come across. A lot of the other questions are a little bit more straightforward. Okay, so we're going to try one more, and then I'm going to let you guys practice them. This unit is going to feel a little bit like the proofs that we did with trig, where I can give you guys some strategies, but I can't say you do this every single time. Does that make sense? So to a point, I can tell you a little bit about how it works, but every problem is a little bit different because there's so many different combinations of clues they could give you, and it would take a lot of hours for me to go through every single situation of what they could give you, okay? So I'm going to hit some of the high points, and then I'm going to let you guys just practice by looking at your own problems. Okay, so the next one we're going to say the major axis is from negative 6, 2 to negative 6, 8, and the minor axis is from negative 3, negative 3, to negative 9, negative 3. And we're going to find the equation. So they told us the points that were on the major axis, the points that were on the minor axis. Anytime you're getting confused on a problem, you should draw a picture. Once you draw a picture, that allows you to start using your common sense, and some of these answers will be a lot easier to find when you're using that, okay? What's the other name for the 2 points that are on the major axis? Those are the vertices, yeah. And then what's the other name for the points that are on the minor axis? Co-vertices, okay? So they told us about the major axis, but they really were telling us about vertices. And they told us the vertices were at negative 6, 2 and negative 6, 8. And they were talking about the minor axis, but they really meant the covertices. And that was -3, -3, and -9, -3. So when we go to write the equation of an ellipse, what's the first thing we typically want to find? The center. That's the majority of the equation, right? So if we have the vertices or the covertices, we don't have to use all 4 of those points, but we can use some of them to help us figure out what the center is. How do we do that? Okay, we'll use the vertices. What do we do with them? Find the middle. Yeah, find the midpoint. So we're going to do -6 plus -6 divided by 2. And 2 plus 8 divided by 2. So what is the center?
-6. 3.
Okay.
That's what I got.
-6, 5. 10 divided by 2. Okay. So how do we start writing that as an equation? We know it equals 1. Okay. So for the vertices, did we go left and right from the center, or did we go up and down from the center? So there's our vertices. Did we go left and right or up and down? We went up and down. How far up and down did we go? We went from 5 to 2 and from 5 to 8.
3.
We went a length of 3, right? 5 to 2 is down 3. 5 to 8 is up 3. So that's 9. Does that go underneath the x's or the y's? The y's, because it was up and down. Okay? All right, then our co-vertices are from -6 to -3 and -6 to -9. Still 3. So is this actually an ellipse? It's a circle. They tricked us. So when they called it a major axis and a minor, they really meant like not. Because that's a circle, which technically doesn't have either of those things. All right. So those are all the examples I'm going to do with you. You really just have to look at the information you have. If you struggle, what should you do? Draw a picture. Draw a picture first, because the picture might clear up all the issues, right? Once you can see it, it might make a difference. Okay, so now you can go ahead and flip to the next page in your packet.